Hey, it's Alex again from Blacksheep IT Consulting. In this third part of our Open UI REST case study, where we explore how to create a dashboard like this, we have already seen in the first part that behind the scenes there is a custom business service working, which we have declared prototype, educational, and really unsafe. So that's why there is no code provided for this one. And using any REST service in Siebel, really, you can use the data service or a custom business service like we do here. Anything that allows you to, well, specify query criteria such as a business component, business object, and search expression, as we have here in the Postman, and that returns the data that you want, the fields that you want. You have a query interface, a query service of sorts that you can call from, well, literally anywhere, including, of course, well, JavaScript. And that JavaScript we use in a physical renderer. And in the second part, and you will find the links to this part 1 and part 2 in the description below. In the second part, we were already neck deep in the physical renderer code, understanding how to generate the UI, that is the button you click, and the empty dashboard, and have a soft-coded dashboard definition. And in this third part, we are going to explore the code deeper and understand how the rendering of the actual dashboard content happens. And this is the final part of this three-part series. So if we look at the get account dashboard config function, which serves as an example to how to store soft-coded configuration data, this is a array of objects that each object defines a dashboard item. You can imagine that this array be stored as records in a database, so you can have a nice Siebel administrative view to generate that data and retrieve it using REST or a business service call. But we choose to put it right in the code here, so we have a least configuration approach. We have a single file that we can share on GitHub for your reference. So this is just one way of doing it, but here we have a clear definition of each and every dashboard item that we want to render. So we have defined, for example, a type, and the charts in the dashboard. Well, of course, dashboards without chart, that's boring. So we want to have charts. And for this case study, we choose chart.js, an open source JavaScript library that is very popular. And so you can go to chartjs.org and get started, download, of course, or get the CDN URL as we look at it, and well, revel in those well, pretty and impressive examples. And of course, you can knock yourself out really with using Chart.js or any other charting library. There's just makes no sense to write your own charting library because there are dozens, if not hundreds, out there. Chart.js is just very popular and easy to use, so that's why we chose it for this purpose. Now in the code, remember that we have to load it somehow, and we use an approach that is dynamic loading through a content delivery network, the URL from the Chart.js homepage. This is an older version of Chart.js, works nonetheless. And we just inject it in the header as part of the init function of this physical renderer, so that takes care that Chart.js is there when we need it. You can, of course, also use the manifest to, well, refer to a downloaded version of Chart.js and load it through the Siebel OpenUI manifest, which is actually the recommended way for production-grade environments, so you don't rely on the internet. What if internet access is not available or intermittently unavailable? then your dashboard will be broken. If you have it local, so to speak, on your web server, well, that's the better idea. This works for a quick prototype. So for these chart types, we want to render the data that we retrieve as a nice and chunky chart. So there are two charts defined, one for quote data, one for opportunity data. And then we have those aggregates. Aggregates that give you the count of orders, associated contacts, or open service requests, or anything related to a customer or total across the database. You define the search spec anyway. And that should be just a big number and the text. So the rendering is really simple. All we need is the record count. The business service returns the record count always, so that's good. So we don't need any extra fields. So that's why the field list just contains the ID, or it could be empty. And we still have a search expression, business component, business object. So when the aggregate type is used and the subtype is count, it will take the record count and show it accordingly. So you can make up any types of dashboard items that you want. We just added, for the sake of a demo, we just added a third one of iframe, where you simply have a URL that you want to render as an iframe. So it has to be a URL that the browser accepts because of the X-frame options usually being same origins. So the security of the modern browsers is very tight, but you can bring in any other, literally any other stuff. Even another Siebel applet if you want to. That would be a nice challenge for the Portlet framework, or Oracle Analytics, former Siebel Analytics, requests or dashboards. Yeah, dashboard in a dashboard. Why not? Okay, but let's not go overboard with the iframe idea. I'm sure that's the easiest solution there. So let's go back to that fetch data function, which is invoked as part of show dashboard. Remember, we invoke fetch data for each of these items in that array. So fetch data is invoked like 6 times in this example. And we already discussed fetch data until where the fetch happens. So if it's not an iframe, then we have to call the REST API to refer to the second part where we discuss this in detail. We see the multiple sessions popping up on the Siebel server, one for each request, and being executed as fast as possible in parallel. And here's the thing, that once the fetch has the results, it calls a render dashboard item function with the results. So the results coming back, and it's passed on to another function. So that's the key function. And there it is. So the function takes the result from the request response, and well, it grabs those database items from the config function, initializes a few arrays, a few other variables, and then we JSON parse data. So we have the response data here. We can get the business component data out of the object data array, and the business component name that's also present in the return data. That's returned by literally as input and output from the business service method. So that business component name serves as a reference here. And it's easy to discern, is there any data or not? Well, we could read the record count, but checking object data length for 0 probably good as well. So we have no data true if that's the case. And now we need to find the matching database item configuration for the current data set, because we have to retrieve it again. So there we loop through those database items array, and we use the business component matching it up. So this is a little bit weird and not really designed well, I have to admit. There can be only one business component, or the business component can be only once in the dashboard. That's not a good idea. So probably need to change that with the ID or something. But for the prototype, it's okay. And so we grab the database item configuration out of the array. So we have it, and we can now break the loop. And if there is data, we can get the record set, the return record set. So now we create the tile. So the tile is already there. It's generated by the function that renders the empty dashboard. And we use the business component name to identify the tiles. Again, an ID would be better. So let's add to do here, use ID instead of BC. So that's maybe just a note here. All right, so we find that empty dashboard item. We call it a tile, but that's just a variable name here. And now comes the switch, literally. So if the configuration type is chart, then we have to get a chart. And if it's aggregate, we have to do something else. So if there is data, then we get the field list. So database configuration has this field list, and for the chart we need at least two fields, label and values. So we expect actually two fields. We push that into an array, and now for each record we get the value of the first field, push it into a labels array, and we take the second field and push it into a values array. So we would have like opportunity 1, 2, and 3 in the first array, and the revenues for each opportunity in the second array. So it's parallel arrays. That's what actually Chart.js wants. Chart.js wants two arrays, at least. And the next line creates the content, and there we have a chart engine function, which is a function I just wrote to wrap the call to Chart.js. So we pass in an ID, a type of chart, and that labels array and data array. So you can see a example call here. So you have an ID of revenue, you want a horizontal bar, you have, let's say, an array of months and revenue here. So that's the input that's provided here. So let's look how we call it. We call it with the label of the database configuration, the database configuration subtype, that's horizontal bar or vertical bar or donut, and the two arrays. So the chart engine is a helper function, really. So it creates it calculates the ID for the chart. It creates the diff container, which for Chart.js, if you look up the documentation how to use it, Chart.js really relies on the canvas element that you have. So we create inside the container an empty canvas, and that we just grab out of the container here. And this is the real Chart.js function. Create a new chart, use that canvas, and there's the instructions here. What type of chart, and the data, the labels, the data set, some hard-coded colors. We could do better than that, but we are happy with that for the moment. And that will return, well, that will return the container, and that contains the canvas, which now has the chart. So it's basically a DOM element that is returned by the chart engine. And that's now in the content. So now we just, well, put some lipstick on the canvas. We say maximum width. So again, anything with style should be in a style sheet, but in this example, we do inline CSS. And then we add some, well, a dash of makeup on the tile itself, no background, remove the text, and of course append the content we just fetched and show it in case it's hidden. Okay, so that's how the chart appears. We use chart.js to generate the chart, and we put it in that empty tile that's already waiting for us. And you know, it shows the spinning globe. And now it no longer shows the globe, it shows the chart. And if there's no data, we just write up in the tile, we just say there's no data for this label. So the aggregate, it's the next type we have. For the aggregate, we just care for the count subtype. We have no implementation yet for average, max, min, etc. So just count it is. So we get the record count from the return data, which the business service puts in there. And then we generate the content as a simple div with paragraphs, one for the label and one for the number. And then we do some CSS. Again, that should be in a style sheet. The number will be a big number, and the label will just be aligned center. And then we will update the tile again and append the content and show it. So we literally generate HTML right here and put it in the tile that's waiting. So the globe goes away and the data shows up. And the iframe is the last type we care about in the render function. If it's an iframe, then, well, the content is, of course, an iframe with that URL as the source. And there's some CSS involved. And again, we update the tile. So there's a little bit redundant code here, really. Not really clever, but works for the prototype. And remember the stats we calculate. So we have an object that contains for each container ID the stats, the fetch start and stop time. And we put an attribute on the tile with a title attribute, so when you hover, it gets a tooltip with the fetch time calculated from the statistics. Okay, so let's see the code in action. So again, let's just pop up the dashboard and see it again. So we see the globes, when we see the charts and aggregated and iframe tiles pop up. Let's do it in a bit more slow motion in the debugger. So here's the render dashboard item function. And let's just look it up for charts. Let's just put the breakpoint right here. And so let's press the button. So now we are just about to call the chart engine. So we have the labels. You see those 3 opportunities, the names of 3 opportunities, and the values, well, the 3 revenue values from these opportunities. And that's the input to the chart engine function. So we have the label from the database configuration, the subtype, horizontal bar, and the 2 arrays we just had. So let's jump over this, and content is now, you can see it's the div with the canvas inside. And now we update the tile. So background set to none, the tile text goes away, and we append, and that's not shown here in the debugger. Funny enough, but that's the way it goes. So there's the second chart, and now we had 2 charts and goes away. Now for the aggregation. So let's get right before we update the tile. Let's show the dashboard. And so we have created the content, which is a a div with the numbers already. So here's the return data record count is 3 in that case. And now the respective tile is being updated. We see 3 associated contacts. That was the contact count that came back here. And then there's the next one, was the open service request and the orders. And there we have it. Okay, the iframe itself is like self-explaining, but for good measure, we just do a breakpoint here. So now the iframe comes first literally because it's not causing any REST calls. It's probably the fastest one to arrive. And we just generate that content, which is an iframe with that URL. And again, we update the tile. And there it is. Yeah, first thing, because it's really just JavaScript and no REST call. Okay, so there you have it. The full code explained how to create a dashboard that fetches data in parallel using Inbound REST API for Siebel CRM. Thanks much for watching. Take care and bye-bye.